Yes, sir. Welcome everyone. This is our first presentation on biostatistics. So in this presentation, we are going to look at the definition of biostatistics, the application of biostatistics, and then the different types of variables. So biostatistics is a science that is concerned with analyzing and interpreting data that is related to biological sciences or health sciences or medical sciences. So this is actually very important because it allows us to be able to make decisions in our practice, whether it is in public health, in research, in healthcare, nursing, midwifery, and any other health sciences. So in the different fields that I've just mentioned, you realize that we apply biostatistics in making decisions on uh, clinical care for a given patient, in medical research, in policy making, and also in deciding which interventions or which public health interventions that can we be able to implement. So this data that we use to make these decisions comes from uh, information that we collect on particular characteristics. Okay, so this data is collected from variables. Okay, so for example, if we are interested in understanding uh, the, the, the the characteristics of patients who visit our medical facility for, let us say, for HIV testing services. Okay, we want to understand which age groups are they? Are they more females than males? Are they working on those that are not working? Okay, so that is what we could be very interested in. So we need to collect information on these clients who come. So that information that we collect that information uh, from them, and that information, for example, the age becomes a variable. Okay, so it is the characteristic of a subject that you're investigating, that characteristic that you're using to get some data from that subject is what we call a variable. Okay, so if the patient comes, you ask them their age, then they tell you that is a variable. They tell you their sex, that is a variable. They tell you their occupation, that is a variable. Okay, so the characteristic that can be measured from a particular subject or object, whatever it is, or whether that is a scientific experiment, that is what we call a variable. So variables come in different types, and it is very important that you understand the different types of variables. We often use the word measurement scales to be able to categorize these different data types that we collect from either experiments or from our research participants or even clients who have come to our health facilities. So we have four of them, and we are going to start looking at the nominal scale. The nominal scale is regarded as the basic measurement scale. In this case, you have different groups, okay, different groups, and these groups do not necessarily have a numerical value attached to them. So, for example, you ask about someone's gender, they will say I'm female, male, transgender, okay. So whether they are transgender doesn't mean anything in terms of numerical value. So you cannot assign them, for example, numerical value of, let us say, 5 because they are female, or 4 because they know it does not have any numerical value, and that is what you call nominal scale. The next one is what we call the ordinal scale, which is basically the fact that the variables have to be ranked in a way. They have rankings, or they possess a kind of order. For example, if you have a patient who is having cancer, you may be interested in understanding what stage of cancer is this patient having, because the stage of cancer may determine the prognosis and also the nature of care that is being provided. Okay, so that kind of order is very, very vital. If you're looking at the order, that ranking is very important. So that ranking has numerical value. Then we move to the next one, which is interval scale. With this, it allows you to categorize data into equally spaced intervals. And we have examples in terms of temperature, which can be measured as Celsius or Fahrenheit temperature scales. The unique thing with this type of scale is that they do not have an absolute, or they don't have an actual 0 point. They do not have that. So if you say that the temperature is 0, you're basically not saying that there is absence of temperature. Okay, the temperature of 0 does not mean that there's no temperature. So there's no absolute 0. Then we move to the ratio scale, which is the most advanced measurement scale. This one also has, this one actually has what we call the absolute value. And therefore, if you say, for example, height is an example of a ratio scale, weight, income. If you say that someone's height is 0 meters or 0 centimeters, whatever it is, it actually means that indeed there is no value attached to that. That means that the variable is absent. Okay, that is what we mean by the true 0 point ratio scale. The categorization of variables can be that we have qualitative and quantitative variables. Qualitative variables are those that we cannot represent basically by a numerical value. They are basically descriptive in nature, people's perception, attitude, and other things. That those are qualitative variables. But we actually say that categorical variables fall under qualitative variables. So the categorical variables are the ones that we talked about, the nominal and the ordinal variables. And then the quantitative variables are the ones which we can call the numerical variables. They can be discrete or continuous. So for example, age, 12 years, that is discrete. Height is continuous. Okay, so we have you can have a categorization of data in terms of discrete data, or continuous data, or quantitative data, or basically categorical data. So you need to be very, very well versed with those terminologies. Then we move to what we call confounding factors. For example, you could be very interested in understanding the relationship between two variables. So for example, you have smoking and the presence or absence of lung cancer. That is something that you could be interested in studying. Okay, so, but as you're studying this relationship, most likely you will realize that smoking increases the risk for getting lung cancer, for example. Now, as you're studying the relationship between smoking and lung cancer, you might have forgotten that there could be another variable that could actually influence the relationship between the two variables that you're investigating. So the third variable that you might not have considered but has an impact on the relationship between the two variables under consideration is what we call a confounding variable. So in this case, as you're looking at the possibility that smoking actually increases the risk of lung cancer, environmental exposures could be something that influences the occurrence of lung cancer, and perhaps you have not looked at. So that environmental exposure becomes a confounding variable. And therefore, if you're conducting any research, it's very important that you take note of confounding variables in terms of your data collection and also in terms of your data analysis. It's very important to take care of the confounding variables. because the presence of confounding variables may influence the final conclusions that you have about your study. So independent and dependent variables. So for example, in the example of cancer and smoking, which one influences the other? Smoking influences the occurrence of of lung cancer. So in this case, the independent variable is smoking, and then the dependent variable is the presence of lung cancer. So often when we are talking about biostatistics, especially in this module, we are going to look at two major branches of biostatistics and then what they actually tell us in terms of public health, nursing, and all the other healthcare or health sciences. So we have descriptive and then inferential statistics. Descriptive statistics actually deal with making sure that data is organized and actually summarized. Okay, that is descriptive statistics. And then the inferential statistics is basically concerned with the fact that we need to make conclusions from based on samples, and those conclusions can be generalized for the whole population. So making conclusions based on samples from the whole population is what we call inferential statistics. So with that, we are basically looking at how hypotheses are made and how we can make general conclusions about the hypotheses that we have actually made. Thank you very much.